Hello everybody, Unit 4, Day 3, talking about reflections. This is kind of just a little, hopefully today's lesson was okay for you, but if you're watching this, maybe you needed some reinforcement on what we covered today in class. Okay, so on the grid below, 3, 7 has been plotted. Okay, so find its image A after reflecting it in each of these following lines. Because what we're looking for is that when we're reflecting it over these line segments, we're looking for the same image but on the other side of that line. Okay, so in this case right here, here's the x-axis, okay, and we're reflecting this point over the x-axis. So the way to think about it is if this was a piece of paper and I were to fold this up, okay, these 2 points would line up. They would fall on directly on top of each other. Okay, so that being said, okay, how far up is A from the x-axis? Well, it's 1, 2, 3, 4, 5, 6, 7. So it means it's going to be 1, 2, 3, 4, 5, 6, 7 units from the x-axis. So this point right here is going to be a negative, oh, I'm sorry, not negative 3, 3, negative 7. Okay, so that's our first reflection. All right, our next reflection is over the y-axis, which is this line right here. Okay, and same process, right? Except we're not going up or down. We're actually reflecting it to the left, right? We're just, well, it's transformation, right? So our new point, okay, is going to be somewhere over here in this area, right? So let's think about this. If we're 3 units to the right from our y-axis here, that means our reflection is going to be 3 units to the left. And again, if this was a piece of paper and I were to fold that in half on that line, those 2 points would line up. And so this is negative 3, 7. So what changed there was our x value, not our y value. Okay, how about reflecting it over the line x equals 6? Okay, so let's draw that line in there, x equals 6. So that's going to be a Vux equation, right? It's going to be centered, or it's going to look like this. Okay, so this is x equals 6. And just like I did for the y-axis, right? In this particular case, I'm 3 units to the left from x equals 6. So my reflection is going to be 3 units to the right, which makes this point 9, 7. And then finally, our last one, right, y is equal to 4. Okay, and so we're reflecting this point A over this line, and so I'm 3 units above, which means I'm going to be 3 units below, and so that's my image, my new image of that point reflected over that line. And I'm going to leave that right there. Okay, and what I'm going to do is I'm going to connect those 2 points. Okay, so it's worth pointing out that not only did I create 2 perpendicular lines there, right? We know Hoy and Vux problems are perpendicular, right? And so this is a vertical, that one's a horizontal. Okay, so they're definitely perpendicular. But what else do we notice? Okay, well, this right here is 3 units. And then this right here is also 3 units. Okay, so when you're creating this reflection, right, not only is that reflection going to be at other point, not only is it going to create a perpendicular line to whatever line segment or whatever line you're reflecting over, right? A prime is certainly perpendicular to y is equal to 4, okay? But also, all right, this reflection point is equidistant from that intersection point right here, okay? So this reflection is equidistant on either side of the line you're reflecting over. Okay? And so if you look at number 2, it says in the diagram at the right, point A has been reflected across line M such that its image, A prime, is shown. Points A and A prime have been connected to form line segment A prime. Ugh, exhausting. Which intersects line M at point B. Okay? So all said and done, okay, what is true about the line segment A prime, and M? Well, they are perpendicular lines. Okay? Next part. What is true about A, line segment AB, and line segment A prime B? Okay? Well, again, if you look up above, right, what is true about those two little line segments? They are congruent. Which means they are equal in measure. Okay. So just keep that in mind when you're creating these reflections, right? Not only does that reflection, all right, across that line, it has to be the same distance from that line as that point, as this point is. This point is equidistant, same as this one here, equidistant from that intersection point, okay? But it also creates a perpendicular line to that reflection, to that line you're reflecting over, okay? So it looks something like this, okay? In which in all those problems up above, that's exactly what happened, okay? So we can use these facts about reflections to find images in the coordinate plane for reflections in not just horizontal and vertical lines, but also lines that are slanted, okay? So, but first we review the graphs of these simple slanted lines, okay? So in the grid at the right, plot y equals x and y equals negative x. State some points that must lie on both of those lines and state the slopes of both lines. Okay, so real quickly, this is the equation. Y is equal to x, okay? Very simple linear equation. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 2. When x is equal to negative 2, y is equal to negative 2. So on and so forth, okay? So our slope here, we're just going up 1, over 1, or just 1. Now, what's the difference between this one and the last one? Well, our x values get switched, right? So if I have x is equal to negative 1, well, y is equal to 1. If x is equal to 3, y is equal to a negative 3. If x is equal to a negative 2, y is equal to 2. If x is equal to a 2, plug a 2 in there, y is equal to a negative 2. Okay, and so what does this graph look like? Well, negative 1 comma 1, 3 comma negative 3, negative 2 comma 2, 2 comma negative 2. Okay, if you weren't familiar with what this line looks like, it's this guy right here. Basically the same line, except going the opposite direction. So the slope of this one is just down 1 over 1, or just a negative 1. Okay, so take a look at these slopes. These slopes are negative reciprocals, right? Which means that these two lines, this y equals x and y equals negative x, are perpendicular to each other. Okay, has no relevance in the sense that of when we're doing reflections, but it's important to point out that those two lines are perpendicular to each other, okay? And so when you're creating these, when you're doing these reflections, you got to keep in mind that when you're reflecting it over these lines, well, you'll see what I mean when I get down there, okay? So let's just try a problem here, right? Before I keep talking about it, all right, let's just do one, okay? So now that we've have those established, let's see what happens when we reflect, okay? So those are those line segments, okay? So let's talk about those, all right? Now, on the grid to the right, okay, the point negative 6 comma 2 has been plotted along with the lines y equals x and y equals negative x. Find the image of this point after, okay, a reflection over the y equals x line. So let's go ahead and do that. I'm going to make that red. Okay, so here's our nice red line. Okay, and we're reflecting it over this line right here. Okay, so in order to create a perpendicular line, right, it's going to have to be, well, it's going to have to be parallel to that line up above, and it's going to look something like this, right? Okay, so how do I come up with that? Well, let's see, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And there is where we intersect, right? Okay, now do the same thing, except I'm going past that line. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And so there is A prime. Okay, so I'm going to connect those two lines. And as you can see, okay, not only did that line segment I create is perpendicular to y equals x, okay, but also I'm equidistant on either side of that reflection line. Okay, so this guy right here is 2 comma negative 6. Let's do the same thing for up above. Okay, so I'm going to go up 1 over 1, up 1 over 1. There's our reflection, or where we intersect the reflection line. So I'm going to go up 1 over 1, up 1 over 1, and there is our reflection across that line. And so that's going to be a negative 2 comma 6. And so without further ado, there's always rules, right? There's always things you could try to, there's always rules you could try to remember, okay? You may try to memorize these, all right? I strongly suggest, though, you just grab a point, all right, and reflect it over those lines based off of what I just showed you, okay? That's the easiest way to try to remember these. You could try to remember these rules until you're blue in the face, okay? But the fact of the matter is you already got enough to try to memorize. So just take a point, all right, reflect it over that line, and then see what rule comes out of it, right? So in this case, in the first one, what happened to our x and y values? Well, it looks like they just got switched, okay? Instead of negative 6, 2, we got 2 negative 6. Okay, but over here, what's it look like what happened? Well, not only does it look like they got flipped, they also got negated. Okay, so in this one here, whoops, it's going to be a negative y, negative x. Okay, let's take a look at number 6. Number 6, all right, this one's going to have a couple transformations in here, right? Not only when we do transformations, you know, most cases, there's always a couple of them, right? We're not just going to do one transformation. We're not just going to do one reflection or one rotation. A lot of times these transformations usually involve a couple of them, okay? So, negative 5 comma 3. So there's our point. We want to reflect it over this line segment right here. Okay? So let's count down to that slope. All right? Let's see. So it's going to be down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. Okay? So do the same thing, except on the other side. So I went down 4 times. And here is our reflection. 3 comma negative 5. But now we're taking this, so I want you guys to take your iPad or whatever you're working on, all right, and we're going to shift it 90 degrees this way. So now we're looking at it such that this is our y-axis and this is our x-axis. And so what is that point now? Well, it looks like that point is 5 comma 3, which is number 1. Okay, so we will cover this tomorrow in class, exercise 7. Okay, and we will also do the other one in class tomorrow as well. Okay, this guy right here, number 6. Okay? So we'll work on both of those tomorrow. For now, just try to do what, just try to mimic what I showed you in those problems above. Okay? Good luck, and